Dear friends, welcome to a personalized episode of Enlighten Me. Today, we dive into how Netflix ensures long-term member satisfaction with personalized recommendations, explore the concept of an anti-roadmap for maintaining a clear business vision, and discuss optimizing preload events for faster web pages. Stay tuned for insights and strategies to enhance your understanding and skills. How can Netflix ensure long-term member satisfaction with its recommendations? At Netflix, the mission is to entertain the world. A crucial part of that mission is making sure members find the right shows, movies, and games at the right time through personalized recommendations. While most systems focus on short-term metrics like clicks or immediate engagement, Netflix is working to deliver an experience that also brings lasting enjoyment. This approach not only engages viewers in the moment, but also enhances their long-term satisfaction, making them more likely to remain loyal subscribers. One way to understand Netflix's recommendation system is by comparing it to a contextual bandit problem. Imagine when a member logs in, that's the context for the system. It then decides which recommendations to show, and the member's feedback, whether they play, skip, give a thumbs up, or even renew their subscription, becomes crucial data. These feedback signals help define reward functions, which train the system to make better future recommendations. Improving a recommendation model can come from various areas, like better input features, more data, or advanced architectures. However, Netflix focuses on improving the recommender objective by defining reward functions that better reflect long-term satisfaction. You might think retention is the obvious reward to aim for, but it has several issues. Retention can be noisy, influenced by factors outside Netflix's control, like seasonal trends or marketing campaigns. It's also slow to measure and hard to attribute directly to specific recommendations. Instead, Netflix uses proxy rewards to gauge long-term satisfaction. These proxy rewards are based on user interactions with recommended content. For example, if someone watches One Piece and then completes it with a thumbs up, that's a strong positive signal. Click-through rate, or play-through rate in Netflix's case, is a simple proxy reward, but it can sometimes promote clickbait content, which doesn't always lead to long-term satisfaction. To get a clearer picture of long-term satisfaction, Netflix looks beyond simple interactions. Fast season completion suggests strong enjoyment. A thumbs down after finishing a show indicates low satisfaction despite the time spent. Watching a movie for only 10 minutes leaves the user's satisfaction unclear. Discovering new genres, like watching more Korean shows after Squid Game, shows valuable engagement in new areas. Reward engineering at Netflix involves refining these proxy rewards. This iterative process includes forming hypotheses, defining new proxy rewards, training a new policy, and A/B testing. One challenge is that user feedback can be delayed or missing. For instance, someone might start a show today but only finish it weeks later. Some might never rate the show, leaving Netflix uncertain about their enjoyment level. To address this, Netflix predicts missing feedback using observed data and other relevant information. This predicted feedback helps train the system, allowing it to adapt quickly to new data. While the system relies on observed feedback, it also uses complex models to predict delayed feedback, ensuring the recommendations are as accurate as possible. Netflix employs two types of machine learning models for this. Delayed feedback. Prediction models, which predict long-term feedback based on short-term interactions, and bandit policy models, which generate real-time recommendations. Sometimes, better offline metrics from these models don't translate to better online performance. This disparity often happens when the proxy reward doesn't fully align with long-term satisfaction. In such cases, Netflix refines the proxy reward to better match the improved model, ensuring positive online metrics before the new model is deployed. In summary, Netflix's approach to recommendations involves aligning them with long-term member satisfaction through carefully engineered proxy rewards and sophisticated machine learning models. This method helps Netflix provide an engaging and enjoyable experience that keeps members coming back. Now that we've explored Netflix's approach to personalized recommendations, let's look at how an anti-roadmap can help companies maintain focus and a clear vision. What does it mean to have an anti-roadmap? This might sound counterintuitive, but understanding what you won't do can be as crucial as knowing what you will. Imagine you're the leader of a company. You have a vision. You want to accomplish great things. But here's a question. Can you name a feature or service that your competitors have that you will not offer? Many leaders struggle with this question. Why? Because the instinct is often to cater to every potential customer request. If some users want a particular feature, why wouldn't you build it? This line of thinking, however, can lead to a lack of focus and a diluted vision. Let's take a moment to unpack this. Not having a clear answer to what you won't do typically indicates that you want to do everything. But can you really do everything? And even if you could, would it make sense? When you design for everyone, you essentially design for no one. Think about a company like IKEA. They aim to create a better everyday life for many people by offering affordable, functional home furnishings. But have you ever tried to book a live chat with an IKEA professional or customize the color and material of a product? You can't because IKEA has decided not to offer these services. Their focus is clear, and it allows them to prioritize what they excel at. Now, let's consider Apple. Their vision is to bring the best user experience through innovative hardware, software, and services. But you won't see Apple venturing into enterprise-oriented hardware or allowing third-party built hardware. These decisions help Apple maintain its premium, seamless ecosystem. The idea here is that a vision should be prescriptive. It should guide what you will do and what you won't do. If you can't name a feature you won't build, even if it might make sense for a competitor, it often signals a vision deficit. Narrowing your market and making something that people will love is more valuable than trying to be everything for everyone. Creating an anti-roadmap can be an enlightening exercise. It helps your team understand your vision through concrete examples of what you won't be doing and why. Much like how a design guide shows the appropriate and inappropriate usage of a logo, an anti-roadmap clarifies what actions align with your company's vision. For example, Ferrari has a clear vision to represent the pinnacle of luxury and performance in the automotive industry. They won't build a budget car or manufacture in China because it would dilute their brand. This clarity helps Ferrari maintain its exclusive market position. In essence, an anti-roadmap is a powerful tool for leadership. It helps guide your entire company toward executing a common vision by showing what to avoid. The main takeaway? Knowing what you won't do is just as important as knowing what you will do. It sharpens your focus and strengthens your vision. Now, let's talk about how front-end developers can optimize preload events to make web pages load faster. What can you do to make your web page faster, even before it starts loading? This is a question that every front-end developer should consider. Typically, when we discuss web performance, we focus on metrics that measure what happens once content appears in the browser. We look at things like first contentful paint, largest contentful paint, and interaction to next paint. These metrics tell us how quickly users can start consuming and interacting with the page. But what about the actions that take place before the first byte of a web page is received by the browser? Can we measure these events and optimize them to make our web pages load even faster? Let's explore this idea by looking at how these preload events are visualized. In Sentry's trace view, these events are captured and labeled as browser spans. 6 specific spans are recorded: cache, DNS, connect, TLS, SSL, request, and response. All these events occur before the time to first byte, or TTFB, which measures the time from the request for a web page to when the first byte of the response arrives. To collect this data, Sentry utilizes the Performance API, specifically the Navigation Timing API. This API provides high-precision timestamps for various performance-related events that occur in the browser. You can access these metrics directly by typing Window Performance in the browser's developer console. This will give you a detailed breakdown of events from the moment a URL is requested to when the page fully loads. For example, the fetch start timestamp marks when the browser begins checking its cache. If the resource is found in the cache, the browser retrieves it without needing a network request. This can significantly speed up the loading process. The time taken to perform this cache check is recorded between the fetch start and domain lookup start timestamps. Next, we have the DNS lookup span. When a user requests a URL, the DNS translates the domain name into an IP address. This process is timed between domain lookup start and domain lookup end. The speed of this lookup can be influenced by the infrastructure of the DNS provider, the location of DNS servers, and the cache time, known as time to live. Following DNS lookup, there's the connection span, which measures the time it takes for the browser to establish a connection to the server. This is recorded between connect start and connect end. If the server uses HTTPS, a secure connection event, secure connections tart, will be recorded. This event marks when the browser and server begin their TLS negotiation to establish a secure connection. Once the connection is established, the browser sends a request for the resource. This is the request start event. Finally, the response start event marks when the first byte of the response is received by the browser, completing the TTFB measurement. Now, how can we optimize these events to improve performance? For cache retrieval, ensuring that your browser cache is regularly cleared can help. For DNS lookups, using a DNS provider with a large, globally distributed network and setting a higher time-to-live value for records that don't change often can reduce lookup times. You can also use the real.dns prefetch attribute on link tags to preemptively perform DNS resolution for third-party resources. For connection and TLS negotiation, using real preconnect can help preemptively establish connections, including the TLS handshake. This can speed up the loading of external resources. Finally, to optimize the TTFB, reducing the number of just-in-time requests and using caching strategies can make a significant difference. Serving static pages from a CDN and utilizing HTML streaming, where the server sends pieces of the HTML document as they are ready, can also help reduce TTFB. In summary, understanding and optimizing the events that occur before the first byte of a web page is received can lead to significant performance improvements. This knowledge allows developers to make informed decisions and implement strategies that enhance the user experience by speeding up web page load times. We've explored how Netflix uses personalized recommendations for long-term satisfaction, the importance of an anti-roadmap in maintaining a clear vision, and techniques for optimizing web page load times. Stay tuned for more updates. Dear friends,